Let's find out auto-scaling and failover in a hybrid cloud environment through a simple demo scenario. The first scenario is a demo of auto-scaling, which involves simultaneous resource expansion in both the public and private clouds when there is a surge in user demand. First, let's consider a scenario where users are accessing a government portal hosted in a hybrid cloud environment. As the influx of users increases, the need for auto-scaling becomes evident. Additionally, the same homepage service is hosted on both the private cloud and the external public cloud, with a global server load balancer configuration distributing 30% of the traffic to the private cloud and 70% to the public cloud. We have configured auto-scaling to trigger when CPU usage exceeds 70%. As a result, in this demo, we will demonstrate how the number of pods in the private cloud increases from 1 of 3, and the number of pods in the public cloud increases from 3 of 7 as a response to this CPU usage spike. We explain more details about the domain configuration and weight settings. Each domain is configured as follows. The hybrid cloud uses representative portal domain, the private cloud uses private portal domain, and the public cloud uses public portal domain. These domains are simultaneously operational in both the internal and external cloud environments. Furthermore, through GSLB Global Server Load Balancer configuration, 30% of the traffic is directed to the private domain hosted in the private cloud, while 70% of the traffic is directed to the public domain hosted in the public cloud. Here is specific demo video. Here is the state before auto-scaling takes effect. The orange border on the left represents incoming requests to the service in the private cloud, while the red border on the right represents incoming requests to the service in the public cloud. You can see that there are 2 pods in the private cloud and 3 pods in the public cloud at this moment. Now, we can check how auto-scaling takes place as the influx of users surges. As user requests increase, you can observe that the container CPU usage rises, triggering auto-scaling. Eventually, the number of pods in the private cloud increases to 3, and in the public cloud, it increases up to 7. Next, let's proceed with the failover demo in which GSLB is used to redirect traffic to the public cloud in the event of a failure in the private cloud. Just as shown in the previous demo, users access the portal domain hosted in the hybrid cloud. At this point, GSLB configuration evenly distributes user requests between the private cloud and the public cloud, both set to an active state with a 50-50 weight ratio. In this scenario, a disaster situation occurs in the private cloud, leading to auto-scaling in the public cloud, increasing the number of pods from 2 of 4. Here is the circumstance before the failure occurs. The orange border on the left represents incoming requests to the service in the private cloud, while the red border on the right represents incoming requests to the service in the public cloud. You can see there are 2 pods in both the private cloud and the public cloud, and user requests are evenly distributed with the same weight. Now, let's observe the situation where a failure occurs in the private cloud. A failure has occurred in the private cloud, causing the services in the private cloud to enter a stopped state, making them inaccessible for monitoring. SLA monitoring settings have detected the failure, and notifications indicating the occurrence of an issue in the private cloud service are being received. As a result of the failure, all user requests that were previously evenly distributed, 50-50, are now being directed to the public cloud. This influx of traffic is causing increasing container CPU usage in the public cloud. The increased CPU usage in the public cloud triggers auto-scaling, and you can observe that the number of pods in the public cloud increases up to 4 as a result of this scaling.